This is a load cell that will pull out the loads when a cabin interior monument such as a galley is tested. Today, a galley is built, bolted to the floor and pulled to the emergency landing loads. If it breaks, it fails. If it stays intact, it passes. This will pull out the loads so you know what's going on in a test. It moves us towards certification by analysis instead of by destructive testing. A large-scale test is very expensive, well over £100,000 if it passes first time. If you repeat it, it's more expensive. If you can use analysis to certify your galley or your cabin interior monument, you can optimise your structure, you are confident that it's going to pass, the risk is minimised, and ultimately you're going to get a more robust, safer design. These load cells represent the fuselage floor and will pull out loading. There's 6-axis load cells, so they're pulling out loads in 3 directions. You've got the tension load and the shear in the 2 directions, and as well as that, the moment, so the rotation. Although a foot might not be permitted to take a moment, the load cell can measure it and check that it's working. Today, if you do a test, all you know is true or false, the galley is strong enough or it's not strong enough. If it doesn't break, you're not learning where your weaker structure is, but if you pull the loads out, you can use it to correlate your finite element analysis to the test to show that what you have modelled is representing the test. Then you can use that to use analysis to predict the strength and demonstrate that what you are doing is representing the behaviour of the galley. And that leads us on to weight saving and substantiation by analysis rather than test. If we're using analysis rather than test, you don't need to produce a test article. You know your strength is good before you've designed your galley, or as you're designing the galley, you are confident, you've removed risk, and we're not wasting galleys that are being built, shipped over and then destructively tested. Although it's developed specifically for cabin interiors, the load cell can be adapted or resized for any structure. It can be used anywhere. As part of this project, we developed a sophisticated data acquisition unit that's at least as fast as anything available on the market, but much, much cheaper. It's using more up-to-date components and processes that can gather the data really quickly. And that's really important when we're moving to electrical vehicles or more testing, that we can really quickly gather data. By getting more data from the tests, we can use that to calibrate our FEMs to the analysis, which we can use to save weight and improve designs.